Hi, Year 7. This is the last lesson on the topic of reactions, and I hope you remember that this little reaction is a combustion reaction with burning wood in the presence of oxygen. I just thought that would be a good way to start. Right, today is about balancing, and on these scales, you'll remember if you put mass on one side, it's the same as the mass of the other side, then the scales are balanced. So the masses have to be equal for the scales to be balanced. I'd like you to have a think about what these scales actually measure. You remember there's a difference between weight and mass. So the question is, do these scales measure mass, or do they measure weight, or do they measure weight or mass? So let's have a look at that. Okay, today's topic is conservation of mass. We need to learn a few things. We need to be able to explain the law of the conservation of mass. We need to be able to use this law to do calculations regarding mass, and we also need to know how to balance easy equations. First of all, here's a little bit of maths revision. C is the same as A plus B, then C is the same as B plus A. And then if we want to find B, it's the same as C minus A. And if we want to find A, it's the same as C minus B. A little bit of maths revision. You think about what the word conservation means. There's some clues in these 4 pictures, and maybe pause the video or spend a little while thinking about the definition for conservation. Okay, this is one definition: preventing loss or decay, remaining the same over time. Right. Okay, so let's look at the law of conservation of mass. Here's a reaction we've done before: magnesium and oxygen. Another combustion reaction goes to magnesium oxide. And on this side are the reactants, on this side are the products after the chemical reaction's taken place. So the conservation of mass law says the total mass of the reactants on this side is the same as the total mass of products on this side. Okay, mass this side is the same as mass there. Here's an example. This is a reaction we're familiar with. We burn coal or carbon in the presence of oxygen, and it makes carbon dioxide. So let's look at the mass of the reactants on this side. The mass of this side is 12 grams of carbon and 32 grams of oxygen. So the total mass on the left-hand side is 12 grams plus 32 grams, which is 44 grams. And on the right-hand side, they've given us the products weighing 44 grams. That shows that the mass of reactants is the same as the mass of the products. Okay, now we have to do a bit of maths while we calculate masses. Just a reminder, what would the product be if you reacted copper and sulfur? And think about the ending of the word as well. Okay, well done. It's copper sulfide. And if they give us, in this reaction, we start with 5.1 grams of copper and 2 grams of sulfur, the question is, what will be the mass of the copper sulfide? So because the mass of products, I beg your pardon, the mass of reactants is the same as the mass of products, we know that we have to add these two together. 5.1 plus 2 is 7.1 grams. There's the little sum. Okay, here's another example. We've done some decomposition reactions where compounds are broken down into simpler compounds. So you might remember we heated lead carbonate in the test tube, and it turned into lead oxide, and it gave off a gas which was carbon dioxide. And we tested the carbon dioxide by bubbling it through lime water, and the lime water went cloudy. Right, back to calculations. The question is, how much lead oxide would you be left with? Because we started with lead carbonate, 3.5 grams. These are the reactants. These are the products. we must have 3.5 grams of products. So we've already got 0.5 grams, so we need another 3 grams of lead oxide, so that the weight, the mass of the products is the same as the mass of reactants. And there's the little equation, and we've got 3.5 reactants and altogether 3.5 products. On the PowerPoint, if you click through it, please go to the slide and look at this video, because this is one of the videos that will come up in questions. It's very common. It's the same: magnesium plus oxygen goes to magnesium oxide.
This is a conservation of mass demonstration that you can do at home and show your family. We're using the ingredients that we've used many times: bicarbonate of soda and vinegar. And I've filled this bottle with I've put some bicarb in that bottle. I need to zero the scales. There you go, 0. So I have to put all the reactants onto the scale before we start. And I need to write down the mass before. So it's the mass of all the reactants plus the containers. So that's 305 grams. And now I'm going to add the two together and then give them a good shake. Okay, so it's 304. So the mass has gone down by 1 gram, which is not what we were expecting. Can you think about where that extra gram has gone? Well, remember that the carbon dioxide gas has escaped from the bottle. So there's a whole gram's worth of carbon dioxide that escaped. So I'm going to do the reaction again and put a balloon on top of the bottle to see if we can trap all the carbon dioxide and see if we can keep the mass before and the mass after the same by collecting the carbon dioxide as well. Okay, we've zeroed the scale, and this time we're going to collect all the carbon dioxide in this balloon. So I'm going to weigh the 2 reactants and all the containers we need to use, and the total weight is 312 grams. I'm going to do the experiment and see how much it changes. So you can see we're collecting the carbon dioxide in the balloon. So now we've kept all of the products. We've kept the water and the sodium acetate, and we've collected the carbon dioxide as well. So now we need to see what the mass after is. Okay, it's 312 grams. So by collecting all the carbon dioxide, mass is being conserved. The mass before and the mass after is the same. So the final mass change is 0 grams, which proves the law of conservation of mass.
Now the next step in this lesson is to learn how to balance chemical reactions. So another way of stating the law of conservation is, on the left-hand side, which are the reactants, there's the number of each type of atom. And that number of atoms has to be the same as the number on the right-hand side. So the number of each type of atoms in the reactants is the same as the number of atoms in the products. And if that's the case, then the reaction is balanced. Right. Let's try balancing some reactions. See how my animation works. Okay, so in this reaction, we're going to react carbon and we're going to react with oxygen, O2, and we are going to make some carbon dioxide. Now let's count the number of atoms of each type on this side and count them on this side and see if they're the same. Right, we've got one carbon this side, one carbon this side, job done. We've got two oxygens this side and two oxygens this side. We're all sorted. So this reaction is balanced. The reaction has the same number of each type at the start and at the end, so it's balanced. But let's look at the next one. Okay, in this one, we're going to react hydrogen and oxygen, H2 and O2, and that makes water. So there's a molecule of water. Now, water has only one oxygen, so we've only got one oxygen on this side, and we need two. So we have to add another water molecule. So we have two oxygens, two of these white oxygen atoms. There they are. So now the oxygen is fine, all balanced. But there's a problem. Now we've got four hydrogen atoms on this side, and we've only got two on this side. So let's add two more hydrogens. And now we've got, it's always good to double check, 1, 2, 3, 4 hydrogens this side, 1, 2, 3, 4 hydrogens this side. Let's look at the reaction. Two H2s makes 4, and here we go, two H2s make 4. So the hydrogen's correct. Here we've got two oxygens, O2, and here, because they're two molecules of water, we've got two oxygens. There they are, 1, 2. So now this reaction's balanced. Well done, year 7. Okay, here's another one that's a little bit more tricky. This reaction is nitrogen, N2, plus hydrogen, H2, and we make ammonia, which is NH3. So these are the steps you can go through to balance the slightly more complex reactions if you can't see them straight away. Usually I just put numbers in front until I can see what they are, how it's getting closer to being balanced. And if it doesn't balance, I choose a different number and I just try around with the numbers until I get the right answer. And the more I do that sort of thing, the quicker I can get them done. But this is a step-by-step system. Okay, so step 1. Check to see if there are equal numbers of atoms on each element on both sides. Okay, that's not going to work because we've got two H's here. We've got three H's there. We've got two nitrogens there and one there. It's a complete mess. So let's look at, there are two nitrogen atoms on the left, but only one on the right. So we have to add a big 2 in front of this molecule. So now we have two nitrogens on the right and we have two nitrogens on the left. That's fine. But we've got two hydrogen atoms on this side and three on that side. So what we have to do now is to add 3 in front of this H2, and then we have 3 2s are 6, and here we have 3 2s are 6. So now that balances. Let's just double check. 2 nitrogens, 6 hydrogens, 3 2s are 6, 6 hydrogens, 3 hydrogens, all times 2. So that's balanced, job done. On this, look at the PowerPoint and have a look at some of these. Things online that you can play with. It's a bit like the ones where we made different molecules. You need to copy and complete this in your books, please. You can choose words from these at the bottom, and so you need to pause the video and complete those 3 sentences. Okay, good. And now you can mark the 3 sentences to make sure that what you've written is correct, and make sure that in your books you've got 3 correct sentences. Okay, once you've done that, we can move on and let's see how well we've done. Can we explain the law of conservation of mass? Mass on one side equals the mass on the other side. The mass of products equals mass of reactants. Can we do some mass calculations? And can we balance some simple equations? So that's today's task. Well done. The next slide is for some people if you're interested in looking at a little bit of quantum physics and how it relates to what we've done. It turns what we've done a bit upside down. So have a look at this slide and see what you think about it. You can read it all on the PowerPoint. Thanks, that ends this lesson, and I'll put up a worksheet for you to do.